If you are familiar with programming, you know what a search is, right? So you're given a number, you're given an array, you try to find the number in an array. For example, here, I would want to search this array for this number. A binary search is a specific search algorithm which expects the array to be sorted. For binary search, it's not okay if I send an array like this. What I would need to do is to sort the array, and then I would be able to search through that. In this step, we'll set up a simple example using Spring Boot to be able to do a binary search. The objective is to understand the concepts of tight coupling and dependency injection. In the previous step, we used Spring Boot to create a simple application, Spring in 5 steps application, and we were able to run it as a Java application. Now we would want to add the logic of binary search to this example. So I'll create a new class, Control N or Command N, and I would want to say new class, and next I would want to call this class as binary search IMPL. I will not use an interface for now, but I'll continue using binary search IMPL, and let's go and say finish. The first step of binary search is sorting an array. Binary search expects a sorted array. When I want to use binary search on an array, first thing is I would need to sort the array, and next I would want to search the array, and after that I would need to return the result. The result is typically the index. So if the element is present in, let's say, position 3, then I return 3 back. How do I design a method like that? One of the things that you need to remember is we are not really going to implement the entire logic for binary search. I would just implement high-level algorithm, if you can call it that way, just to get you understanding about tight coupling and loose coupling. Let's get started with a simple method. So now I would want to create a method to do a binary search. How would the definition for that would be looking like? Public int. So I would want to return the index back. So it's an int. I would want to call this method as binary search. The inputs for a binary search, as we discussed earlier, are an array. So I'll pass in an integer array. I'll call this numbers and the number to search for. So the first step of binary search would be to do sorting, right? So first you'd implement all the sorting logic here, implement sorting logic here, and then you would actually implement the search logic here. And after searching the array using binary search, you'd return the index of the result back. So let's say the index where it is found is 3. I would return 3 back. I'm just returning 3 to make the compiler happy. This is how your binary search algorithm would look like, right? So you just need to implement your sorting logic here, you would implement the search logic here, and then you would return a 3 back. Now I would want to use this binary search algorithm. One thing to remember is this is just a dummy algorithm. It's not really a real thing. So all that I would need to do to be able to use that here. So I'm opening up the Spring in 5 steps application class, which is in directly here. So I'm going here. I would want to use the binary search IMPL. So I would need to create an instance of it. So binary search IMPL, binary search is equal to new binary search IMPL. And I would want to do a binary search. So I can say binary search dot binary search of, I would need to pass in an array. So I'll create an array directly here. So new int with, let's say, few numbers, 12, 4. I'm having a little bit of trouble with the auto thing. So let's type in 3 for now. Let's just have 2 numbers in the array and say save. And now I can go ahead and make it 12 and 4. So what we have created in here is we are sending in array, and this is the number we would want to search for in the array. And let's do a sys out of this, or what we can do is we'll take it to a variable. So int result is equal to this, and we print the result. Actually the result is not really important. What we want to try to understand here is the concept of loose coupling. So let's run the JUnit test. Oh, actually it's a Java application. So right click, run as Java application. You would see that at the start 3 is printed because that's the result of this specific thing, because that's what is written back from here. That's cool. Now we have implemented a simple dummy method for doing a binary search. Let's say this is using the sorting logic is implemented by using bubble sort algorithm. You don't need to really worry about what the bubble sort algorithm is. It's one of the algorithms. So let's call it algorithm 1 or bubble sort algorithm. So let's say I have bubble sort algorithm which is used in here. This logic of binary search is tightly coupled to the bubble sort algorithm. What I mean by that is that if I want to change the algorithm, then I would need to change the code of the binary search. That's what tight coupling means. This binary search IMPL is tightly coupled to the bubble sort algorithm which is present in here. And that's not really good. Let's say over a period of time, things evolved and there's a new sorting algorithm. Let's just take quicksort for an example. I'd want to switch this to quicksort. Then I would need to change this piece of code to be able to use quicksort. Think of another scenario. So sometimes I want to use bubble sort, sometimes I would want to use quicksort. How do I separate them out? How do I make them loosely coupled? One of the things that we can do is we can actually start implementing a algorithm for bubble sort outside. So let's start with a simple thing. So let's start with taking bubble sort outside this search. So how do I do that? What I would do is actually start with creating a new class. So I'll start with creating a new class. I'll call this bubble sort algorithm. Bubble sort algorithm. Let's say this is the one which can do the sorting. So now I would say public. A sort algorithm takes an array of numbers and returns an array of numbers. So I'll say int and sort int numbers. This is what a sort algorithm does. You would put all the logic in here. So logic for bubble sort, and then you can return the sorted numbers back. One thing which is important for you to understand here is that we are not really implementing the logic. Let's assume that the logic for bubble sort is implemented in here and we are returning numbers back. So now this particular program has the capability to sort. So what I can do now is I can use bubble sort algorithm here. So bubble sort algorithm, so I'll call this bubble sort algorithm is equal to new bubble sort algorithm. Instead of, and to do the sorting, what I can do is say bubble sort algorithm dot sort numbers, and I would actually receive the result. So I would call it int sorted numbers is equal to bubble sort algorithm dot sort. So now this sorting logic is moved out. I can just implement the binary search logic here and return the index back. So the sorting algorithm of bubble sort is moved out. That's cool. Bubble sort is outside the ambit of binary search. So if anytime there is a change in logic of bubble sort, all that I need to do is change the logic here. Nothing else needs to change. I have not solved the problem of being able to change the sort algorithm dynamically. So I would want to be able to run this binary search different sorting algorithm. In a way, this is better because this is now the sorting algorithm is now moved out. But still, I have the problem of not being able to change the algorithm. So let's say I quickly create a quick sort algorithm. So I'll just Control C, Control V, and I have a quick sort algorithm. Quick sort. So I'm not going to change anything in here. I'll just leave the logic as it is, and just let's say the logic for quicksort is what is being implemented in here. So now I would want to be able to switch between quicksort and the bubble sort algorithms dynamically. I would want the search algorithm, the binary search algorithm, to be more loosely coupled. I would want to be able to pass in the sort algorithm in. How do I do that? Think about it. This is more of a Java problem. Just think about it, and we will find the solution for it in the next step.